Okay, so today we are going to learn how ionic compounds are actually chemically named. So you may have already heard or known about these names before, but we're going to expand upon the formula writing that we've already been doing. So I'm just going to look at this table with you guys really quick so that we can kind of get acquainted with a few things. So first of all, you'll see that I have color-coded sections of the table. You guys need to know this. Like, I cannot just emphasize enough how you have to have a periodic table or a number of them labeled to your benefit, because they are your bread and butter. That is, the periodic table is going to lead you to the right answer, okay? So what I want to point out is that you have a huge portion of the table that is colored either this light orange or yellow color. These are all metals that get involved in ionic bonding, okay? So everything you see that is yellow or orange is a metal. So the metals with the yellow highlighter, all right, are the metals that have definite fixed charges. So all of these metals are always going to be 1 positive. These are always 2 positive, meaning I have 1 valence electron that I lose. I have 2 valence electrons that I lose. Aluminum and gallium are always 3 positive, and then these 3 transition metals right here, zinc and cadmium, are always 2 positive, and silver is always 1 positive. Now, this section, anything that you see in orange, these are metals that have variable charges. So, for instance, what this means is the element titanium, for example. So, titanium has multiple states of valence electrons, meaning that sometimes it might have 2 valence electrons, sometimes it might have 1 valence electron, okay? So let me show you what that looks like. This is what I wanted to show you, and so I misspoke with the titanium. Titanium, it can actually be a 2 positive or 3 positive. It's copper that can be 1 positive or 2 positive. So all of these that you see that are colored or shaded rather with orange are metals that don't always have the same ionic charge because their valence electron counts can vary, all right? So just keep that in mind, because that's going to play a really big role in how we actually talk about our formula writing today, okay? Now, so I'm going to erase these just because you guys don't have to know these and aren't supposed to know them. Now, all the rest of them that you see up here, you should know. You should know that all the elements right here, these metals are always 1 positive in the alkali metals. These in the alkaline earth metals are always 2 positive. These 2 are always 3 positive, and then these always have definite charges, all right? So you need to know that. You also need to know the other piece of this, that the nonmetals in groups 15, 16, and 17 also have definite charges, all right? So nitrogen and phosphorus are always 3 negative. That is, they gain 3 electrons to become stable. Oxygen, sulfur, and selenium are always 2 negative, and then fluorine, chlorine, bromine, and iodine are always 1 negative because they gain 1 valence electron. Now, keep in mind, these are metalloids. They might fall as a metal or a non-metal. We'll talk about those when we get to them, but these are the ones you need to know for sure. Now, carbon is a sharer. That is, it shares and does not get involved in ionic bonding whatsoever. And then these noble gases do not at all, again, because they are stable. So when you're naming an ionic compound, one of the key features, and probably the primary feature you have to remember, is that the metal's name will never change. All right, so all of these metals that we see up here, their name does not change at all. You just write it like you see it, okay? Now, the non-metals, and again, that's only going to be these right here, all right? So there's very few. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 non-metals that are involved in gaining electrons in ion bonding. These, their ending will change to IDE, okay? So what that looks like would be, for example, with the combination of, let's say we have sodium and chlorine, which is a very popular ionic compound, which is table salt. So the metal is sodium. We don't change the ending. And then chlorine would become chloride, okay? So the ending is no longer INE, it's IDE, all right? So that is a standard thing that occurs in ionic bonding, is that the nonmetal's ending will change. So if you have a nonmetal, one of these that I just showed you guys, one of these 9, okay, the ending will change to IDE, all right? So if you had calcium and oxygen, it would become calcium oxide. If you had rubidium and nitrogen, it would become rubidium. You don't change the metal's name. Nitrogen would become nitride, okay? So I'm going to give you a worksheet that shows you how to actually change the spelling on these, on the suffix, all right, how to drop it and actually change it to IDE. Okay, so I'm just going to show you. It's just really simple and easy to take any of these and write out their name. Not a whole lot of work. So like, let's say that we had potassium and the element chlorine come together. So that would be potassium. And then chlorine would become chloride. Okay, so you would no longer have the INE and it would change to IDE. So this is how you write names for the what are known as binary ionic compounds. Okay, so binary meaning two. It is two elements, one metal, one non-metal. Okay, so what I've been using or referring to the last couple examples is one of your metals with a fixed charge. So one of the ones in yellow with one of the active non-metals in ionic bonding. So what happens when we are using one of these metals that don't always have the same charge? Like, how do we write it same? And we do write it differently. Okay, so I'm going to kind of clear out the screen a little bit and go over that with you guys. Okay, so as mentioned just a second ago, when potassium and chlorine come together, you have potassium chloride. Now, something that has already been touched on and I've already went over with you guys is how you can write the formula as well. So you have the chemical name. I'm just going to write CN for chemical name. And then you have the formula, all right? So the chemical formula is where you have to balance those ionic charges. So because potassium is 1 positive and chlorine is 1 negative as an ion, and we can see that up here, chlorine or potassium is 1 positive, chlorine has a 1 negative charge. All we have to do is come down in here and say, okay, that's going to be just KCl, because these charges equal each other out. They cancel each other out. So these can come together. These elements can come together in a 1-to-1 ratio. Now, so whenever we write the name for an element such as chromium, so here we've got chromium. Now, chromium is different because it is a metal with a variable charge. So when you have a metal with a variable charge, unlike potassium or any of these that are in the yellowish kind of gold color, when you have one with a variable charge, the naming is different, okay? The naming, you have to actually use the ionic charge. So here's what I mean. So the chlorine is going to be the same. So let's go ahead and write this out. So this is going to be chromium. We're not going to change the name of the metal, all right? We never change the name of the metal. Just like potassium, state potassium over here, chromium gets to say chromium. Now I'm going to do something right here that is necessary, and I'm about to explain in a moment. I'm going to put an open and close parentheses, and then I'm going to write chloride just like I did over here, okay? You have chlorine that becomes chloride, okay? The ending changes to IDE, all right? So what's with the parentheses? So the parentheses is there for the charge on chromium, all right? So now at this point, we don't know the charge on chromium. We know the charge on these metals, right, that are in yellow, but the ones in orange are kind of a mystery to us. Even if we were told, hey, chromium can be this, or this, we don't know exactly what chromium ion is right here, what ionic charge goes here. So you have to figure it out. So if I were to tell you, and in order to figure it out, you have to have the formula. So let's go ahead and do that. So if I tell you the formula for this chromium ion is or this chromium ion within this ionic compound, let's say the formula is CrCl2, okay? So again, this will be given to you guys. So unlike this one where you guys had to figure it out with these known metals with fixed charges, all right? When you have a transition metal, or that is a metal with a variable charge, you will be given the formula and you have to use it to figure out what goes here. So the way that you do this is you go, okay, my formula tells me that there is 2 chlorine ions or 2 chloride ions and 1 chromium. That's what this says. It's a 1 to 2 ratio, all right? So I need to figure out what goes here. Like, I'm going to have to put the charge right here. So what you have to do is go, okay, chlorine, I know its charge, right? Chlorine is a nonmetal with a definite charge. It is 1 negative, today, tomorrow, and always. So chlorine is 1 negative. All right, so if that's the case, I'm kind of working backwards from what we were doing with these formula writings last week and then yesterday when it was reviewed, is that there are 2 negative charges total. That means there has to be 2 positive charges total. So that means that the charge on the chromium is 2 positive. So this is what we need to go right here. Because until we broke down this formula into the 1 chromium and then the 2 chlorines and then used chlorine's known charge, which is 1 negative, we could then determine that, hey, if that's 2 chlorines, that means the overall negative charge on this compound is 2 negative, so the overall positive charge has to be 2 positive. So that's going to be the charge, which goes here. But here's the catch. You don't get to come over here and write 2 positive, all right? Can't do that. So this is what's called the stock naming system, all right, in chemistry, all right, in chemical compounds. So in the stock naming system, you cannot write charges like this in parentheses. They have to be represented as a Roman numeral, all right? So we're going to write those down real quick over here. So the Roman numeral 1, which is going to be 1 positive, Roman numeral 1 is just an I. Roman numeral 2, which is going to represent the 2 positive charge, is 2 I's. Roman numeral 3 is 1, 2, 3, what we call 3 I's in the Roman numeral naming system. 4 positive is going to be an I, then a V, all right? Because a V represents 5, and that means 1 before 5. 5 positive will be represented with just a V, all right? 6 positive is going to be V with another 1 behind it. Okay, so you guys are going to get a copy of this. So you don't have to memorize these at all, but you do need to know how and when to use them. So you need to know that, hey, chromium is one of those orange elements. It's one of those metals with a variable charge. So when I write its chemical name, I don't get to do like I did with potassium, just write potassium chloride, like just change the ending to chlorine. But if I'm going to have chromium with chlorine, chromium does not have a definite charge. So I have to put parentheses right here where I'm going to actually put the charge, but I don't know what it is yet. And then I'm going to change the ending of the chlorine to IDE as I did over here. But I have to figure out the charge by using the formula. So this will be given to you. You use that formula. You take that chromium, you take those 2 chlorines, you say, okay, I don't know the charge on this yet, but I do know the charge on chlorine. Since there's 2 of them, this has to be 2 negative. That's going to make this 2 positive. So that's the charge on my chromium. But we have to use what is known as the stock naming system. I can't just write 2 positive here. I have to put a Roman numeral 2, which represents 2 positive. So this formula right here, chromium, this CrCl2 represents the chemical compound chromium 2 chloride, all right? So you see that there's a bit more work involved in naming or giving the chemical name of an ionic compound, right? We were talking about ionic compounds where there is a metal with what is known as a variable charge. Okay, so we're going to take a look at a couple more of these so that you guys can kind of get the understanding of how to do these. So let's say that we have the element zirconium. So this is a transition metal. This is one of those metals with a variable charge. Let's say zirconium is going to bond with oxygen, all right? So we're going to give you guys the chemical formula for that. So we've got zirconium and oxygen. Okay, so this is the formula. It's been given to you. So how do I write the name? All right, so that's going to be zirconium. And since zirconium is one of these metals that doesn't have a definite charge, I'm going to have to put a parentheses right here. And then I'm going to take this oxygen and I'm going to make it oxide. So we're going to drop the ending and change it to IDE. And so now I've got to figure out what's the charge on this zirconium. Since it's not definite, since it's not fixed and known, I got to figure that out. So I'm going to use my formula to figure that out. My formula says there's only one of these for every one of these. So that's one zirconium for every one oxygen. Don't know the charge on zirconium? That's what I'm going to put right here as a Roman numeral. Remember, we're using the stock naming system. All right, so I'm going to go over here and say, oh, well, oxygen has a definite charge. Let's make sure we use that. If this is 2 negative, all right, and this compound has to be overall chemically neutral and have a charge of 0, that means that this is a 2 positive charge right here, that zirconium has a charge of 2 positive. And once again, 2 positive is represented with Roman numeral 2, and that's what we're going to put in the parentheses. All right, let's do another one. Let's say if we have Fe2O3, all right, it's like, hey, how do I name this? Well, Fe is right here. That is one of my metals with a variable charge. This is the element iron. That's what Fe is. I'm going to put a parentheses because it does not have a fixed charge. I'm going to have to figure the charge out and put it here. Oxygen becomes oxide. Again, I'm going to give you guys a printout of how you change the endings, like the suffix on these nonmetals to IDE. And so now I'm going to use this formula. I'm going to have to figure out the charge on the iron. So according to the formula, there are 2 iron ions. That's what this 2 means. And I've got 3 oxygen ions. Don't know the charge on the iron ions, but I do know the charge on oxygen. Oxygen has a 2 negative charge. And since there's 3 of them, that's going to be 6 negative charges total. Well, that means I have to have 6 positive charges total, because that's the only way I can have this neutral, stable ionic compound. So that means that, well, if this is 6 positive and there's 2 of these, I've got to divide this between 2. So 6 divided by 2 is 3. So that means that the ion, the metal ion, the identity of the iron in this compound is an iron 3 ion. It is an iron atom with a 3 positive charge. So I'm going to go over here and say, okay, 3 positive as a Roman numeral would be 3 of these. So that is what I would put right here, iron 3 oxide. The biggest mistake students make is they think that what goes right here in parentheses is this. Oh, this is iron 2 oxide. There's 2 of them. No, this is not a subscript of how many ions. It is the charge on the metal ion that is unknown, right? It has a variable charge. So you take the formula, you break down the ion counts, which is 2 to 3, and then you use that non-metal that has that definite charge. You put it there, you figure out, oh, hey, this compound has 6 total negative charges. That means it has to have 6 positive charges, and since there's 2 of these, we will divide them, and that's where the 3 comes from. So this is iron 3 oxide. Keeping in mind that this is only for the metals that we see over here in orange that don't have a definite charge. Don't forget, if you have something like calcium chloride, okay, that it's just calcium. Take the chlorine, change the ending to IDE, calcium chloride, and that's it. There is no parentheses with a Roman numeral because calcium has a known charge. It's always 2 positive. So since these in orange do not always have a set charge, we have to determine that by breaking up the formula. So we'll end today with one thing, and that is, what if you are given the name, but you need to go back and write this formula, okay? So let's say you have one of these metals with a variable charge, and the name is given, and you're asked to provide the formula. That is, this is the chemical formula, right, for these 2, and you need to give those for this particular one right here. Well, you're going to look up platinum, and platinum is actually right here, number 78 on the table,
its a chemical symbol is PT. Iodine, or excuse me, not iodine. I was looking at the Roman numerals. All right, so oxide is actually oxygen. So oxygen right here is just a chemical symbol O, right? So now you can't just write down the chemical names. You have to balance the charges, just like we did when we were naming, say, lithium with nitrogen. You have to balance out those charges, all right, so that you have equal amounts, right? So same thing here. This is a charge. Roman numeral 4 represents 4 positive. So you're going to place that here. And then oxygen is forever and always will be 2 negative. So you're going to put that here. And you can see they're not equal. So just like we were doing prior to today's lesson, you have to have equal positive and negative charges in the ionic compound. So you're going to have to write another oxygen ion. And when you do that, that allows you to have a net charge of 0. That it allows you to have 4 positive charges, 4 negative charges that cancels out to 0. So we would write this formula as 1 platinum ion for every 2 oxygen ions. So this would be PtO2. So the biggest thing in the formula writing is that you guys know and keep in mind that this right here is a Roman numeral that represents the charge on these metals that don't always have a definite charge. So you have to determine and figure out what it is based on the chemical formula that's provided. The formula will allow you to break down the metal and nonmetal ions and kind of work backwards to figure out the charge on that nonmetal. You guys are going to get some more extra practice or get a practice set with these and get a packet so that you guys can know how to drop the endings and change the IDE on all of these 9 nonmetals, as well as the Roman numerals, so that you guys can also use and identify those as well.